In this video, we will start with the radar, module 5. These are the topic that we have to discuss in this portion, in this particular module. First of all, radar, the simple radar equation, pulsed radar, continuous wave radar, equation for Doppler frequency, frequency modulated continuous wave radar using sideband super heterodyne receiver, MTI radar and its delay line canceller, MTI radar with the power amplifier and power oscillator, non-coherent MTI radar, radar transmitters, radar receivers, and radar displays. Uh, See, radar means the full form of radar is radio detection and ranging. It is an electromagnetic device for detecting and locating remote objects. These are the functions of a radar. We can find out the position of particular object. We can find out the distance of the object from the location of the target, or it is termed as a range of the radar. We can also measure the size of the object, and it is very important. We can identify whether the object is stationary or moving. If it is moving, it is away towards the target or moving towards the target. Also, we can find out the direction of the movement. In addition to that, we can find out the exact velocity of the moving object. So this is the simplest block diagram of a radar. So the radar basically consists of a transmitter and a receiver, and usually a common antenna is used, and this antenna is used on a time shared basis. So this antenna can be connected to transmitter or receiver, not at the same time. So, and this is made possible by a duplexer. We will see what is duplexer in the later slides. And when the transmitter is usually transmit an electromagnetic signal to the target. See, suppose this is the target that we have to identify. After transmitting the electromagnetic signal towards the target, so what happened is that the target will uh, reflect some of the electromagnetic signal towards the radar itself. Okay, then some part of the radiated signal towards the radar is collected by the receiver section, and it is processed to get the further information. Usually the returned signal, I mean the signal which is back to the radar is considered as echo signal. Now, this is what I have already explained. Transmitter radiates electromagnetic signal into the space by antenna. A portion of transmitted energy is intercepted by the target and radiated back in many directions. Signals radiated towards radar is collected by an antenna and delivered to receiver, where it is processed to detect the presence and range of the target. A single antenna can be used for both transmitting and receiving on a time shared basis if the signal is periodic pulses. Now let's see, I have already explained what is duplexer. Duplexer means a single antenna it can be used in a radar. So this antenna can be shared on a time shared basis. So this is happened by a particular duplexer. So these are the functions of a duplexer. See, to isolate the receiver during the transmission and separate the transmitter while receiving the echo signal, to protect the receiver from high power transmitter, to help using a single transmitter receiver antenna. Once the transmitted pulse is emitted by the radar, a sufficient length of time must elapse to allow any echo signal to return and can be detected before the next pulse may be transmitted. So ഇവിടെ കൺസിഡർ ചെയ്തിരിക്കുന്നത് ഈ നമ്മൾ സെൻഡ് ചെയ്യുന്ന സിഗ്നൽ പൾസസ് ആയിട്ടാണ് കൺസിഡർ ചെയ്യുന്നത്. ഒരു പെർട്ടിക്കുലർ ആഫ്റ്റർ സം ടൈം അനദർ പൾസ് ഈസ് ഗോയിങ്. ഓക്കെ, അപ്പോൾ ഒരു പൾസ് പോയി അതിൻ്റെ എക്കോ തിരിച്ചു വന്നതിന് ശേഷം മാത്രമേ അടുത്ത പൾസ് വിടാൻ പാടുള്ളൂ. അതായത് ഫ്രീക്വൻസി ഓഫ് ദാറ്റ് പൾസസ് വളരെ കുറച്ച് കൂടുതലായിരിക്കണം. അപ്പം ഇപ്പോൾ അടുത്ത പൾസും കൂടി പോയിട്ട്, അപ്പോൾ ഒരു പൾസ് പോയി നെക്സ്റ്റ് പൾസ് പോയിട്ടാണ് തിരിച്ച സിഗ്നൽ വരുന്നതെങ്കിൽ ദർ ഈസ് സം പ്രോബ്ലം. അപ്പോൾ ഏത് പൾസിൻ്റെ ആണെന്ന് ഐഡൻറ്റിഫൈ ചെയ്യാനായിട്ടൊരു പ്രോബ്ലം ഉണ്ട്. അപ്പോൾ അത് നമ്മൾ അടുത്ത സ്ലൈഡ്സിൽ എക്സ്പ്ലെയിൻ ചെയ്യുന്നുണ്ട്. അതിൻ്റെ കുറച്ച് റീഅറേഞ്ച് പഠിക്കാനായിട്ടുണ്ട്. ഓക്കെ, so this is the range to a target. So R is equal to CTR by 2. R is equal to range in kilometers or nautical mile. TR is the round trip travel time in microseconds. TR is the round trip trip transit time. അപ്പോൾ ഇവിടെ by 2 കൊടുത്തേക്കുന്നത് round trip ആയതുകൊണ്ടാണ്. The factor 2 appears in the denominator because of the two-way propagation of radar, where c is the velocity of the light. Okay. Now, so we know that electromagnetic signals in the velocity is equal to velocity of light. So we can consider the velocity of electromagnetic signal is c into tr divided by 2 is the range of a target. ഞാൻ ഓൾറെഡി പറയുന്നത് once the transmitted pulse is emitted by the radar, a sufficient length of time must elapse to allow any echo signal to return and detected before the next pulse may be transmitted. If the pulse repetition frequency is too high, echo signal from some target might arrive after the transmission of the next pulse, and ambiguities in measuring range might result. Echoes that arrive after the transmission of the next pulse are called second time around echoes. So this is very important. Echoes that arrive after transmission of the next pulse are called second time around echoes. Such an echo would appear to be much shorter range than the actual and could be misleading if it were not known to be a second time around echo. So this is the equation for second rounded up echo, c divided by 2 into fp, where fp is the pulse repetition frequency in hertz. Now, this is very important, simple form of the radar range equation. So, radar range equation. Radar equation relates the range of a radar to the characteristics of the transmitter, receiver, antenna, target, and the environment. It is useful not just as mean for determining the maximum distance from the radar to the target, but it can serve both as a tool for understanding radar operation and as the basis for radar design. Let PT be the radiated power, and if an isotropic antenna is used, the power density at a distance r from the radar transmitted power divided by the surface area, that is 4 pi r square of an imaginary sphere of radius r equal to pt divided by 4 pi r square. So this is the transmitted power pt. So ഒരു പെർട്ടിക്കുലർ റേഡിയയിൽ ഒരു ഇമാജിനറി സ്ഫിയർ കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ ആ ഒരു പെർട്ടിക്കുലർ പോയിന്റിൽ കിട്ടുന്ന power density is pt divided by 4 pi r square. pt is the transmitted power, 4 pi r square is the imaginary sphere area ആണ് at a particular പോയിന്റിൽ കിട്ടാൻ ചാൻസസ് ഉള്ള power density, that's pt divided by 4 pi r square. ഇനി അടുത്തതിൽ നമ്മൾ ഗെയിനിൻ്റെ ഒരു കൺസിഡറേഷൻ കൂടി കൊടുത്തിട്ട് ഈ ഇക്വേഷനെ മോഡിഫൈ ചെയ്യും. But the radar employs directive antennas or direct the radiated power PT into some particular direction. So if we consider the gain of the antenna, we can rewrite the equation like this. Power density from directive antenna with the gain G equal to PTG divided by 4 pi r square. Now, so this PTG by 4 pi r square ആണ് ടാർജറ്റിൽ എത്തുന്നത്. Then ഇനി ഇതിൽ എന്താ ചെയ്യുന്നതെന്ന് വെച്ചാൽ പവർ ഡെൻസിറ്റി ഓഫ് ദ എക്കോ സിഗ്നൽ അറ്റ് ദി റഡാർ അവിടെ കൺസിഡർ ചെയ്യേണ്ടത് ഇന്റർസെപ്റ്റിംഗ് ഏരിയ കൂടി കൺസിഡർ ചെയ്യണം. ദ റഡാർ ക്രോസ് സെക്ഷൻ has a unit of area. It is characteristics of the particular target and is measure of its size as seen by the radar. So this is the characteristics of the particular object. So the receiving power density PTG divided by 4 pi r square into sigma into 4 pi r square. Now, if the effective area of the receiving antenna is denoted as AE, the power P received by the radar is, we have to multiply this effective area to this particular equation. So this is very important. The sigma is the intercepting area of the target and AE is the receiving power, the receiving antenna area. So this is the equation for power received by the radar. From this equation, we can calculate the range of the equation. So this is very important. ഇത് പല കോമ്പറ്റേറ്റീവ് എക്സാമിനും ചോദിക്കാറുണ്ട്. ഇതിൻ്റെ പവർ ഈസ് ഇൻ ദ റേഞ്ച് ഓഫ് r/4, ഫോർത്ത് പവറിലായിരിക്കും റേഞ്ച് കാണിക്കുന്നത്. So if you consider this power P received by the radar, detectable minimum signal, ഒരു മിനിമം സിഗ്നൽ എങ്കിലും ഉണ്ടെങ്കിൽ മാത്രമേ we can detect the target. So if it is equal to SM, we can calculate the R maximum, or we can express the R maxima like this. Then, but the relation between gain and, so this is simplest relationship between the gain and AE for a particular antenna, G is equal to 4 pi AE by lambda square.